Okay. Good morning, everyone. My name is Sundari Borganti, and I work. I do the QA, and I work with customers on most of the Hadoop and NoSQL implementations. And I'll go over a few of the implementation details and sample activity reports. If you have any questions, please post them in the chat or hold them till the end when we will have a question and time for questions and answers. Now, I'm going to start with where we want to place STAPs in a Hadoop cluster, and whether each of these components, the blue boxes, whether they're different physical machines or basically the same physical machine, we need STAPs running on each of these components. The name node and the standby name node, basically because if the name node fails and traffic switches to the standby name node, we don't want any break in the auditing capability. So therefore, we need STAPs on both the name node and the standby name node. We need one on the job tracker and or the resource manager. You can only run either MapReduce v1 or Yarn at a time. So whichever one you're using, we need an STAP on that system. And then on the HBase master and on the Hive server, and and whatever clients, I guess, you're using to speed up your queries, like Big SQL, Tez, or Hawk, for example. Now, you might ask why we don't have Impala here. For Impala, we don't need an STAP on the servers. We only need them on the daemons. And as you can see below, at the data node, we need STAPs on all your data nodes if you want to capture Impala traffic or the big SQL worker traffic and HBase traffic. We will need STAPs also at the different regions. Now, the reason for this is because HBase, for example, does not want its master to become a bottleneck, so it caches a list of where each of its tables are at the client. So the client goes directly to the HBase region. Impala, for the speed, it does the same thing. And Big SQL, we do it because we need to, for security, customers are able to log into each of the Big SQL workers and run queries from there too, and we want to make sure that we are able to capture when a privileged user goes to the worker directly. Now, this is a quick example of how we would do, we would capture from one port in STAP. So let's say the Hadoop client, which is usually a Linux box sitting somewhere. So I log in as Sundari and I run an Hadoop FS -ls, for example. So, or I run a word count job. So we capture, so the word count job sends it across 8032, which is the Yarn resource manager, and 60,000, which is HBase. So it goes through the KTAP, which is the kernel tap, which Kathy was talking about. It's a shim that sits on your operating system. So we look at it and we say, oh, hey, yeah, we recognize this traffic. It's MapReduce or it's HBase. And then it sends it across to the Guardium G machine, basically. So it sends, what the KTAP does is it's sitting in between your Hadoop cluster and your and the G machine. So the traffic flows through the KTAP. We send one copy over to our G machine, and then it flows through and runs, obviously, on your Hadoop cluster. So we just make a copy of the traffic. We are not doing anything else with the traffic. We make a copy of the traffic in order for us to look at it, so we can record it in our appliance. So configuring inspection engines. Now, as Kathy has been talking about in the beginning, there are a lot of different components for Hadoop. And obviously, each of those components have their own ports. Each of them have a server component and a client and a slave. They have a master-slave component, and then they have, so it is confusing. So it's important for you to know what ports you're using, because you could set up custom ports. So it's important to know what ports you're using, and then set up your inspection engines that way, so that you're not, basically, I guess if you look at it, you could say, I want to set up my ports from port 8000 to port 75,000, and then yeah, you'll catch everything in between, but you also catch a lot of junk that you don't need. And here, as important as it is to capture the right amount of traffic, it is just as important not to capture too much traffic. So we have Guard APIs that will actually help you create inspection engines once you know what your ports are. And as you can see on the right, we have what type of inspection engine it is. Is it like HTTP or Hadoop, or in terms of big SQL, it's a DB2 inspection engine. So now Kerberos. As most of you know, in production, Hadoop systems in production always use Kerberos. And in order for us to decrypt the Kerberos usernames, we need some extra setup done at the STAP side. If you're using Big Insights and Guardium Proxy with Big Insights, then Guardium Proxy will do it for us before sending the traffic to the G machine, so you don't need any special setup. But for big SQL, you will need to set up DB2 exit so that you can capture the Kerberos traffic for DB2. And for everything else, we have special instructions, like Kathy was talking about the deployment guide. We have special instructions in the deployment guide that will give you more in-depth instructions on how to find out what your key tabs are and where to set them up and how to set them up. So now I'm going to move on to talk about Hadoop policies. So we have a sample Hadoop policy that is shipped with the product, but it is a very simple Hadoop policy. You will want to add on to that policy as you go along and you understand more about the traffic patterns in your system and what traffic you want, your audit and compliance rules. So there are a lot of factors. It's not like the policy that we ship is the policy that everybody is going to use all the time, right? For example, if you look at the first policy that's up here, so if you look at this policy, for example, here, this one, we are skipping, the first two rules are skipping objects and commands that are not really important and are uninteresting, basically, so that we can save space on the G machine, right? And then we are saying filter based on server IP, basically log full details, so you can see everything that's happening on your system. And then we've added a sensitive data access, so you can log a policy violation. But really, log full details takes up a lot of space on your G machine, right? And you don't really need it other than for privileged users. So the second policy, this one, if you look at it, what we did is we're saying privileged user access only for log full details. All other traffic will basically fall through as allow all. So it's not going to be as much space. And then we still have the unauthorized access to sensitive data. So here is an example of what we are filtering out. So you can see these are like HBase, old logs, and user preferences. These are objects that are not really interesting. What you want are your the objects that you have created and the files that contain sensitive data. Those are the ones that you want to really monitor. These are pretty much uninteresting ones. So this is the same thing for the commands. Get cluster status. The Hadoop system talks a lot to each other. The name node needs to check that all its data nodes are, alive and well. So when it does have to send a MapReduce job, it knows it does not want to send a part of the job to a dead node and hence have the whole job hung up, right? So they're always talking to each other, and we don't really need to look at heartbeats and get status and that kind of thing, right? So we filter those out. And this group is being updated, like every time we ship something, we update it with other stuff that we notice. And it's a group in Guardium. So those of you who are familiar with Guardium, you can pretty much add to the group, delete from the group, and based on your system requirements. So this is again part of the policy that we ship with the product. So we have this not Hadoop servers because most of the customers have relational database or basically non-Hadoop servers that run with on the system. So this policy, what we want to do is we don't want to, if you were using logful details, just the default policy, we don't want to do logful details for all your traffic, right? If you have Oracle, MySQL, DB2 systems connected to this, you install this policy on top of your other policies that you have. So that's why you have to put in an IP here of basically IPs to filter out traffic from. You can remove this condition. This is just another policy, so you can change it as required and remove the condition if needed. So this is an example of a sensitive data incident. So basically, what we are saying is sensitive data objects that are accessed by privileged users. So this is what you want to do. So we are saying, in this case, we are saying just, show it in incident management on the Guardium UI. But in most cases, customers would either get email or phone alerts, or you would send it to a SIM system. Here is an example of an HDFS report, and you already saw part of this report with Mike. So as you can see here, we get all your server IP, client IP, who ran the thing. As you can see, I ran it, and then the verb and the object name. So you know exactly what's happening in your system. Web HDFS. So this is an example of if you use Hue, for example, which is Cloudera and Hortonworks UI. If you use Hue to create files or access files, then it uses it through an HTTP REST API called a Web HDFS. So we capture that traffic also, and so you can see here you have a get file status and then an open when I click on the file. So I clicked on the file called customer.data, and you can see here that there were two rows that resulted from that. So I'm going to give a quick high level just to remind you what a MapReduce job is. Basically, a MapReduce job is something that brings structure to unstructured data. So if you have, in this case, if you look at this example, we have an input document, right? And in a customer case, an input document could be anything from a web log to just a log files to web click data, Macy's.com website, for example. So it could be anything. In this case, we are just using a very small document to do this. So if I say that I want to count all the words that are there in this thing, usual real life analytic queries would be what places did Sundari go in the Macy's.com website. So you would search for Sundari anywhere that Sundari went, right? So you would know I went to shoes, I went to perfumes, so on. So what we are doing here is you write your MapReduce job and then you send it to your Hadoop cluster. Task tracker or your resource manager breaks it up, and then it sends it to each of its nodes with a small piece of the input file. So what the Java program does is in its own piece, it counts whatever words that you're looking for. It counts those words, and then it sends it back to your task tracker or your resource manager. So as you can see in the map part of it, everything is one, right? Because we, in this case, we have two nodes. Now, in the job tracker or the resource manager, in the final reduce part of it, adds up together. It says hello 1 plus 1, so that's 2. World 1 plus 1, that's 2. And then 1 IBM and 1 buy. So that's how MapReduce works. Now, and here is how we look at the MapReduce report. So as Kathy mentioned, we have MapReduce 1 and MapReduce 2, which is also called Yarn. And for each MapReduce job, it creates files. It deletes all the temporary files, and then it accesses your input file. So it's a lot of traffic. So what we do is we have a MapReduce report which basically filters out everything other than complete and create. So you have only 2 rows per MapReduce job, because if you think about it, at a customer sites, you have hundreds of MapReduce jobs, or you should anyway, running queries, analytic queries throughout the night or during the day, whatever. So we break it up into just 2 we only show 2 queries in the MapReduce report, so it's easy for you to see what MapReduce jobs are running on your system. and you can take a look at are there jobs that are authorized by you or not. And this is an example of MapReduce 2, which is Yarn. So as you can see, it's different. So it says submit application. So we pick up on submit application, and then we also get the MapReduce job name. So for Yarn, this is how you would fix Yarn site.xml will tell you what your resource manager address is and where it is. So this is an example of an HBase. So HBase, as Kathy mentioned before, is a column-oriented database system, and it runs on top of HDFS. Now, here are the ports. And if I create, for example, so I'm creating a table called blog with the two column families called info and content. So what we see across the wire for this particular command is a create table. So as you can see, the verb here is create table, and the object is blog. So you can see that if, for example, you wanted to have an alert when anybody creates tables, let's say, who is creating the tables and what permissions are they giving to each other. So, you could have a report that only looked at create table, for example. So this is another example of put. So in this case, what I'm doing is I am adding to the table blog a row identifier called mat001, and in content I want to say that it's a post basically, and the contents of this post is do elephants like monkeys. So we caught it, it's a multi, it comes across as a multi, or put comes across as a multi, and we have the object name here. You can see mat001 there as an object. So we are filtering out the extra characters in our next report. So now if I say get blog, now as I explained, mat001 is a row identifier for the columns of content. Right? So if I say get blog mat001, you can see here that I have two objects. I have blog as an object and mat001 as an object. I have both of them, so you can basically alert on or look at whichever part of it, like at a higher level, at the table level, or at the row identifier level. If you have only certain rows in your table, for example, that contain sensitive data. So this is an example of a Hive report. Now in Hive, I have to mention here that the Hive command line or the Hive CLI, when you use it on the client, what the Hive client does there is if you say select count star from credit card or select star from credit card, it breaks it down into the thrift commands or the MapReduce commands before sending it across to the Hadoop cluster. So since we don't have STAPs on the client and we only have STAPs on the Hadoop cluster, we can only see traffic that comes across there. So for Hive CLI, you will see MapReduce and HDFS traffic and not the select star from credit card, because it is not sent across the wire. It's broken down when it's sent across the wire. But if you used hue beeswax, then we will catch we will show you exactly what your commands were, but I have to mention here that these are all computed attributes, so they are not actionable. So you cannot say, there is an object called default June 15, I want to act on it. So PIG is a programming language and a runtime environment for processing data sets. So usually the way people used to write MapReduce jobs were, you would say, pick up a file from this location on this disk and run this analysis job on it, right? Now Hadoop, the cluster, manages itself. So which means that if it thinks that this particular node is getting too full or whatever, based on your replication, it could move your data file to a different node, right? So it's no longer where you expect it to be. So because of this problem, what they did was they set up PIG. So PIG basically abstracts over the physical places of your the physical the directories where your data resides. So as you can see here, you basically say load using pig store, put it into your pig, and then you dump it, right? So you're retrieving the information. And this results in a MapReduce job. So again, for pig, we will catch the MapReduce job and the HDFS output, basically because they are not, again, pig breaks it down before it sends it over across to the cluster. So we cannot capture your whole pig thing. And Oozie is again another workflow scheduler system to manage Apache Hadoop jobs. This is an example of how you would run like a sample, basically. That's what I ran from the Oozie dashboard. And you can see all the HDFS commands. So this would be, again, HDFS and MapReduce. That's how we would capture it. And Scoop is a command line interface that is used to pull your relational database traffic into like Hive or HBase, for example. And this is an example I'm saying I'm importing from a SQL Server database sample into the table called CC call log, right? And as you can see here, it is creating a table called CC call log for me, and the thrift message, right? You can see the thrift message where the call log is, and you can see the HDFS traffic and the MapReduce traffic where the table was actually created. Now, Impala is an open source. It's a massively parallel programming SQL query engine for data stored in Hadoop. The problem with MapReduce jobs is MapReduce itself, one anyway, was optimized for large files. So if you have small queries, it takes a long time, like for Hive, for example, it takes a very long time to run the query using MapReduce. I mean, a long time as in relatively a longer time. So what Cloudera did was built Impala, which bypasses the MapReduce framework completely, and then executes. It's a super fast query engine, basically. So as you can see here, this is an example of an Impala query that I'm running on the Impala shell. And this is the report that we will see from that. You can see the username. Now, the thing with Impala is it uses the default user ID in order to connect to HDFS. So just monitoring HDFS is probably not good enough for your compliance and audit requirements. Hence, for Impala, we gather the traffic a little differently. So this is Big SQL version 3.0, which is coming, which is out with the Big Insights version 3 right now. So we don't support Big SQL prior to version 3.0. This requires a patch 210 plus, and for encrypted connections such as Kerberos and SSL, it requires DB2exit. You need to use DB2exit. And this is an example here of the traffic that we would catch, right? So basically DB2 traffic that has been, new commands have been added in order for them to look at the Hadoop traffic. And this is, again, bypasses the MapReduce system and is a massively parallel, super fast query and analysis engine. So there are, these are just a few components, and I'm already running out of time. There are a whole bunch of other components that we support looking at MapReduce and through MapReduce and HDFS. So I'm just going to go quickly over a few of the reports that we have found customers have found useful, and we're always looking for feedback on what kind of reports you're looking for. So first of all, when you plan for the reports, look at what groups you need, and and then create your queries. There are sample queries in this section for read commands, write commands, etc. So some of the reports that we have here are based on full SQL, but like I mentioned before, you can change it to be not using big SQL. Now, this is a permission report, which is very useful for you to see what is happening on your system, right? Who is giving permissions to whom, what kind of permissions are they giving? So as you can see here, I'm giving myself root permissions, which is in a customer and production environment, imagine it's not very good, right? So this is a useful report, I think, And this is the query builder for this report. So set owner and set permission are what we see across the wire. So then we have privileged users accessing sensitive data, which is very similar to what Mike was showing and the policies that I was showing you. So basically, I'm saying customer.data is the sensitive data, and as Voraga, I am a privileged user, so anything that I do shows up. Now I have to mention here, it will show up here even if you run a MapReduce job, you run a Hive query, whatever you do with that file, we will catch it. And so you can see the query here. We are saying if DB user is in privileged users or object is in sensitive objects, then it belongs in this report. So Mike was showing you, Hadoop view commands and Hadoop write commands. So this is very similar. It's read activity. So if I do a cat and I'm reading this customer.data, then you can see here get file info and get listing. So these are the different commands that are part of this, the Hadoop read activity. Now, Hadoop write activity is also very similar. So if I do a put or a make there, then it will show up in this report. So these are the add block, complete, create, or if I delete, right? And then this is permissions exceptions report. So if you have somebody who's trying to access your sensitive data or getting a lot of access controlled exceptions, then I think it would be really useful to take a look at it. So these are in general examples of Hadoop exceptions, of all the different exceptions. So we have already looked at the Hadoop MapReduce v1 and Yarn jobs. So these are just the query builders which you can go. Now I want to quickly go over what strategy you would use for testing and deployment, and this will evolve as we get more and more feedback from customers. So first of all, we are saying start by monitoring HDFS, because everything happens on HDFS in Hadoop. And then based on the different way that you use Hadoop, all the jobs and everything else, then add MapReduce, Hive Server 2 if you're using it, HBase if you're using it, Impala, Big SQL, add on, but start with HDFS first and see, if you can monitor production environment first. So that's all I have. I know I went over really fast at the end, but I'm going to pass it back to Kathy for questions.
So while you're thinking about that, I want to remind everybody about the upcoming Tech Talks. Once again, if you are going to be responsible for, implementing Guardium and Hadoop, you can send me an email and I'll send you a draft. Maybe not this week, but soon, and we'll appreciate getting feedback on that. I wanted to put up a couple resources here. One of them, this one here on the bottom, the Developer Works article, which is based on 1.x. That includes, some step-by-step instructions on configuring inspection engines, et cetera. So it's a little bit dated, but I think the basic idea is pretty much the same. Just to remind everybody, if you're not on the Infosphere Guardium community on Developer Works, which is the fourth link down here, I really encourage you to join, because I'll send out notices for upcoming Tech Talks, and it's easier for you to get the materials that we include on these Tech Talks.